In this lesson, after the students plot the points, most of them applied the Pythagorean theorem. They counted the units, which was 3 and 4 on each side of the legs for the triangle, and they applied Pythagorean theorem a squared plus b squared equals c squared correctly to find that the value was 5 for the hypotenuse. And some of them knew that that was the most popular Pythagorean triple anyway. So if we had c squared equals a squared, would have been 3 squared plus 4 squared, and that's going to be 9 plus 16. And I just kind of turned the formula around and traded sides with how you normally see it, just so they can represent similar to the distance formula. So that's going to be c equals the square root of 25, which c is equal to 5. And then I show, well, it's related to the distance formula, because distance formula says if you subtract, distance formula is this, if you subtract, and they've seen this before in 8th grade also, x minus x1 minus x2, or you can subtract them the other way around, plus the difference of the y value subtracted in the same order, just indicating point 1 and point 2 as all the subscripts mean, square that, and that's going to be your distance formula. So I'm going to show how that's related to the Pythagorean theorem, and you can apply either one to find the distance between 2 points on a coordinate plane. You can either draw the right triangle and apply the Pythagorean theorem, or with just the coordinates of the endpoints of a line segment, apply the distance formula. So we're going to have, if you had the distance is equal to, for the a we had 3 minus 0 to represent that expression, so because the y coordinates would have been 3, 1, so the x coordinates would have been 3 minus 0, because this is 0, 1, so the x coordinates would have been 3 minus 0 is that expression. That's going to be squared, plus the other leg was represented with the expression, the y coordinates, this is 0, 5, and this is 0, 1, so the y coordinates would have been 5 minus 1 would have been the expression on the vertical line segment. And then we could have plugged that in to find the distance of the oblique line segment, the slanted line segment. So the expression was 5 minus 1, which would give you 4, and then you take the square root of that is equal to the c, or the d in this case for the distance formula. So you get the same thing, distance is equal to 3 squared is 9, 5 minus 1 is 4, squared is 16. And it wouldn't matter the order that you subtracted the coordinates in, as long as you subtract them in the same order for the x and the y points, y coordinates of the points. And because when you square a negative or a positive number, you're going to end up with a positive number. So that's going to be square root of 25, which is also 5. And then I go through and show another example to students where it doesn't come out so nicely, but it comes out a decimal, where you still see that the distance formula applies. And that's what we talk about in B, is that you can apply the distance formula without actually seeing the picture and just using the coordinates.